Hey, hi friends. So today we'll try to solve this problem. Minimum number of operations to move all the balls to each box. So the objective of this tutorial is not to code with you, but to build our mental model and to know the ways how to approach these kinds of problems in an interview. And we'll try to find out a pattern or the hints after reading the question, that in which path we should proceed when we will be asked this kind of questions in interviews. So let's get started and read the problem first. So here you have been given n boxes and you are given a binary string boxes of length n, where boxes of I is 0, and if the ith box is empty then it's 0. If it's non-empty, that if it's 1, then it contains a single ball. In one operation you can move one ball from a box to an adjacent box, and adjacent means that the uh, absolute value of I minus j is 1. That means it's obviously adjacent. And note that if after doing so there may be more than one ball in some boxes. Now you have to return an array answer of size n, where answer at index I will be the minimum number of operations needed to move all the balls to the ith box. And each answer is calculated considering the initial state of the boxes. So let's take an example and try to understand what the problem states. So suppose if I take three slots. So there are three slots, and here this is 110. That means here there is a single ball, there is a single ball, and there is no ball over here. Now what you need to uh, return, basically an answer array. What does the answer array means? Suppose you are your answer array is, for example, this is zeroth index, this is first index, this is second index. So this, the number at zeroth index will determine if how many operations you will need if you want to take all the balls from other slots to zeroth index. Similarly, for fast index, it will matter that for how many balls you need, how many operations do you need if you want to transfer all the balls to first index. Similarly, for second index. Now, here we can see that for the fast answer, if I can see that there is already a ball over here. Now, there is a single ball over here. Now if you want to transfer this ball over here, since these are adjacent and this is one ball, so this will count as a single operation. So now there are two balls. Okay, so the answer for the zeroth index is 1. Now suppose you want to bring all the balls to the first index, then a ball is already there over here. Now you need to bring this ball over here. This will count it as a single operation, so here is also 1 will be the in the answer array. Now for example, over here you need to bring all the balls to the second index. In the second index there is no balls, so there are remaining two balls. You need to bring all the balls to the second index, and you need to do it in minimal number of operations. So either, so you can only change from one slot to its adjacent slot. So first you have to bring this ball over here. This counts as operation 1 because there is a single ball you are moving to its adjacent slot. Now there are two balls. Now the two balls you need to bring it over here. So this will count for two operations because there are two balls and you are moving to its adjacent uh, index. So here your answer would be 1 plus 2 is equal to 3. So your final answer will be 1 comma 1 comma 3. Now if we verify with this is 1 comma 1 comma 3. So we'll try to see this with a complex example in the example 2, but let's try to find out what's the intention for this problem and what will be the way if we want to do it in a brute force manner. Suppose there are 5 slots. Now if we want to do it in a brute force manner, then we need to evaluate for each index that how many operations will be needed to bring all the balls from there. So suppose there is a single ball over here, there's a single ball over here. So you can't transfer a ball directly from here to here. You need to bring it via adjacent indexes. So from here, if I want to bring the ball over here, how many counts it will take? One, two, three, four. So it will take four operations, and from here it will take one, two. So you can see that if I am doing in a brute force manner, I will first do it for every index. That suppose I am doing for ith index, I is equal to 0, I will check for some other index. If the value of that give the given array is 1, that means there is a ball over there. I will just calculate the difference of the indexes. So if this is 0th index, 1, 2, 3, 4. So in order to bring this ball to here, I will have 4 minus 0, 4 operations. 1, 2, 3, 4. In order to bring the ball from here to here, I will have to do 2 operations via adjacent indices. 1, 2. 2 minus 0, 2. So then here my total answer will be 2 plus 4 is equal to 6. So here I am able to calculate that the answer will be 6 at the 0th index. Similarly, we can do it for index 1, 2, 3, and 4. So now if there are n number of slots, what will be our time complexity? Because we will be doing it for every index. So n, and we'll be checking the other remaining slots, so that will be of order n, so it will be O of n square. Now how we can optimize it, we need to think about that. Let's go to the optimization part, how we can do that. Again, I will take an example of this: 0 0 1 0 1 1, 0 0 1 0 1 1. So there are 6 slots, and I need to give an answer of also the same size array. There are 3 slots. Now you will check that whenever we are going forward from left to right, try to understand the intuition. Then we can use a prefix array, that how many counts we are taking if there's a ball over here. Suppose I am going from here to here, then here I got a ball, then over here. So at this point, I know that how many balls I have already considered before, and all those balls we need to bring into this position if we want to evaluate the answer at this index. Then suppose I am over here at the last index, for example. So how many balls I have experienced until now? 2. Okay. Now in order to bring these 2 balls over here, how much count of operations we need to do? Can we pre-compute it? Yes, we can pre-compute it with the help of another variable. Like whenever there is one over here, okay, I will do the intuition in some other way. Suppose here you have experienced one, okay. Now all the balls, suppose imagine all the balls you have already brought to this spot. Now you want to move that all the balls to its adjacent index. How many operations it will take? It will take the number of balls you have in this spot. If there are x number of balls, then you will be needing x operations. So these x operations that we will need, that we can store it over here. So I will try to make it more clear by taking another example. Suppose I have this like 1 1 0 1 1. Okay, there are 5 slots. I am only computing that how many permutations, sorry, how many combinations we will be needing to get all the balls from the left of its indexes. If we can evaluate from the left of its indexes while iterating the array from left to right, we can do the same by iterating from right to left when we have to evaluate that how many how many combinations or how many ways we will be needing to bring the righter balls to the particular index. So what we will do, we'll first take a prefix count. That means how many number we have already experienced. So from the zeroth index, there are no left balls, right? So the answer will be 0. This is the answer only for the balls towards the left. Okay. Now then again, when I am getting this as 1, so my sum becomes as 2. But before making my sum as 2, I will store the previous I will store this one in another variable. For example, car. So what will happen that if I am at fast index, I want to bring all the left balls from left hand side, then my count will be 1. Now when I am at over here in my second index, there is no ball and my sum is 2. Okay, so I my sum is 2. So we can imagine we can imagine that those two balls have already been placed in the previous spot. Now if we want to make those two balls to this adjacent index, then we will get two operations, and also I have to add this single operation because this ball I have already bought over here. So this count, that means the count of the previous index, I am storing it in car. So if we use two variables, then it will be very useful for us. So this is 2 1 plus 3. Now this 3, I will store it in a variable current car. Now since this is already 0, we are not updating the count of sum. That means we have also only encountered two balls. Now when I am at this third index, that means here we have already got two balls. Two balls have been taken over here to this position by how many operations? By three operations. Now, if two balls I want to move it from this index to this adjacent index, how many operations it will take? It will take two operations because there are two balls. And what is the total number of operations? The total number of operations is 2 plus 3 is equal to 5. Because in order to bring all the lefter balls to the previous index was 3. This 3 I was storing in the uh, current variable. So if I do at every iteration sum plus current, and I'm storing at the same index, then I will get the answer. So here it will be 5. Similarly for here, I have, okay, now here it's 1 we have encountered. So I will, after updating this count, I will plus 1 to the sum. And now coming over here, we have already got 3 balls over here by 5 steps. Okay, so 5 is the car now. And I need to transfer 3 balls from this index to this index. So in for transferring 3 balls, there are 3 operations, and there was already 5 previous operations. So here the answer will be 8. Okay, so now we have got one result array 0 1 3 5 8, which indicates that how many operations it will be needed if we want to bring all the balls at a particular index from the left. Okay, now what was our ask? Our ask was that we need to bring all the balls both from the left and the right. It's not mentioned, but that has to be assumed. So we will do the same kind of exercise from right to left. So whenever we will be doing from right to left, I will do it for you. So here is 1. So there is no balls towards right. So it will be 0. Now from, so my current is, so my sum is now 1 because I have experienced one ball from here. Now from here, if I come over here, so it will be 1 because sum is 1 and car is 0. Now I have set car is equal to 1 because one operations I have already made. Now from here, if I am going over here, like we are given 0, so there are two balls. Now sum has been increased to 2. So two balls, two operations plus pre-existing operations plus 2 plus 1 3. Then there are three balls. There are now if I come over here, then we have got two balls and there are three operations. So 2 plus 3 is 5. Then if I am coming over here, we have got already three balls. So to order to transfer three balls from this index to this index is 3 plus the previous operation is 5. So it will be 8. Now this array, we got what is implies that what are the number of operations you need to carry out if you want to bring all the balls from the right side. So now if you do a simple plus, like 0 plus 8 8, 1 plus 5 6, 3 plus 3 6, 5 plus 1 6, 8 plus 1 8 plus 0 8, then you will get the final answer. So I think it's clear that how I basically approach the problem and what's the intuition of the problem, how you can do it in a time complexity of O of n. So we are only iterating once from left to right and another time from right to left. So this can be done in O of n time complexity. You can try to make this example 2 in this manner, and you can also code it. I think it's clear. So thanks for this today. Yeah, you will get the code in the comments and the caption section. Thank you.